Introduce you to a special guest of ours. This is the person who discovered Hartley 2. So this is Malcolm Hartley from Australia. Welcome.
Thank you.
So how does it feel to have a NASA mission go to your comet?
Well, it's absolutely awesome. I'm overawed by everything that's happened in the last couple of weeks.
It's been very exciting.
It's amazing.
Would you be able to kind of tell us about how you discovered it? This happened, what, 26 years ago?
24 years ago.
24 years
ago. 1986.
Okay, so it was over 20 years ago you discovered this comet.
Smudge.
It was a smudge.
Smudge, that's right.
That's how you saw it?
Yes. On a photographic plate taken as part of a sky survey, which was the work that we were doing on the UK Schmidt telescope in Siding Spring Observatory in Australia.
And we have an image of that. We have a picture of the observatory. This is where you currently work?
That's right, yes.
And you were taking a survey, and were you looking for any sort of change that the star field?
I was looking, well, I was actually doing quality control of the photographic plate and noticed a very faint image with a telltale glow around it, which is a signature of a comet and not an asteroid.
I think we have that discovery image that you took.
Yeah,
there it is. So that was the telltale smudge.
That's right, so to speak. Against the background of stars, which are obviously stationary. We took another plate a couple of nights later. We gave the positions to the Minor Planet Center in the United States, and they worked out a trajectory or an ephemeris for the comet. And it was a new comet. It turned out to be not one that was already known. And the convention is it gets a catalogue number, which is 103p, but you also get your name attached to it as well, and so that's why it's Hartley.
And Hartley 2 is quite spunky, I understand.
It's very exciting and very interesting for the science team here, and quite a challenge for the engineers, but they're very clever engineers at JPL.
But so much new information will be gained from this because it has much different characteristics than any of the comets we've seen before.
Seemingly that's right, and well, there'll be enough data downloaded to keep researchers busy for the next 5, 10, 15 years probably. It's proving to be very, very interesting, and I'm looking forward to seeing what the outcome will be over the next few weeks and further down the track.
All right. Well, Malcolm, thank you so much for joining us. I hope you enjoyed your stay here. It's a real pleasure to have you here, and welcome to JPL.
It's been terrific to be here.
All right. We are supposed to be getting images quite soon now, and we'll be standing by.
There we go. That's 100 seconds. Yeah, that's our seconds. 20 shades and everything. Looks like an exclamation point. I'm over with a dumbbell.
Go DDS. Yes, these are indicating that the GDS file. Okay, copy that. I'll run my queries. Thanks, GDS.
Right away. It's the next one. Okay. So 100 seconds was the first 100 seconds out. Second one is 34 seconds out. 34 seconds. Okay. Yeah. This is exploration. Good. Looks like Mike. Looks like a honey cow. Mike, instant analysis. Two cometesimals stuck together through what kind of process? Champagne cool. What? Gee. Thank you. Congratulations to you too, though. We're going to have a lot of fun explaining that shape. It's got a rotational rate, doesn't it? Pretty fast. It's very like bear spot.
Hey, Lex, did you ever think it was like this? Well, I saw the peanuts outside.
Amazing.
Next one should be closest to approach.
Next one is closest. Yeah, it's like it's like a pawn. It's like a pawn.
This was 34, 5 seconds out. What's the next one?
Next one's closest to brother. Oh, this is great.
Closest approach.
There, Mr. Hartley. There's Mr. Hartley.
But you were taking pictures all the way, not just at 35. And
Oh yeah, we just
Okay,
just
right.
throughout.
This is just a selection of teasers.
Yeah, exactly. You got it.
This is 34 seconds.
It's like a movie
The others
teaser.
won't be down barely before the press conference.
Everybody ready?
It's got a jet. It's got exhaust coming out the back end.
It's like a Star Wars fan. Unbelievable. Amazing.
Now we'll get 135 seconds on the way out. So a different perspective looking.
We were allowing for a 30-second timing insert.
Now I assume the sun is out over here, right?
Sun's right. Sun's right. Do right.
Yeah, sun is coming up like this. Yeah. Yeah, we agree.
This is almost like in celebrity.
Is that a star it's pointing to? Was that star there?
No, the crosshair on there.
Oh, it's a cursor. It's a cursor.
Yeah, somebody's got a cursor.
It just happened to be along the axis of the
Exactly.
sort of the direction.
Incredible. Mike, may you be busy for a long time.
Now, can you trust the albedo differences there? Is that dark really dark? And dark material?
No, it's all dark. It's all dark. The bright one is just the geometry where the sun is hitting it at the right angle.
All stations PM. Congratulations on a fantastic flyby. Good job, everybody.
With you. Your auto nav is off by about a quarter frame.
Yes, it is. I'm sorry. I apologize. Incredible.
Go ahead, Prop.
We just executed our nominal scheduled VSAT.
Roger.
My friend for 45 years. Well done.
It's happy hour already.
Yeah, there it is going away. This is me. We just rewrote the history book.
Yeah. I just have been
So we have seen at least 4 of the closest approach images, and they have been stunning. Don, it was just as you had predicted. It looks a bit like a peanut.
Right. It does. This is the type of moment that scientists live for, just to get a new result in such a dramatic fashion, and the images look crystal clear. The science team is going to go on for quite a while with these data.
Now, these shots were taken as the spacecraft was approaching, then right at closest approach, and then when it swung past. So on one of the earlier images, you clearly could see the jet.
You can. Yeah, the sun again is off to the right.
Okay.
So you can see the icy surface of the comet throwing dust and gas toward the sun, and you can see that rather clearly. You have this peanut-shaped object that's sunlit on the right-hand side, and down in at 4 o'clock, you can see the jet coming off toward the sun. So the jet starts at cometary sunrise and reaches a peak at cometary noon, and then shuts off at cometary sunset.
So scientists will be focusing on the jets. This is such a great example for them to study. Are you looking for telltale signs of where could be the origination spots of jets?
Exactly. How do these jets form? Is it a pocket of volatile ice that rotates into sunlight and then throws out gas and dust? Or is it somehow coming from well beneath the surface, which seems likely? So the heat of the sun penetrates through the surface dust and reaches the ices, and the ices start vaporizing. Are there more than... How many jets are there? Perhaps 2, 3? Is the whole comet outgassing, with the jets just being the maximum?
From your view, does it look like it's just a single jet at this point, or it's more than one?
There's a single obvious jet coming off toward the sun, but in subsequent images you can see a jet also coming down at about 7 o'clock. So there's more than one jet, and that was evident even before the encounter from some of the modeling that had been done in some of the photometry, or the optical images of the atmosphere.
Now, these are images from the medium resolution camera.
Look at that one up there. You can see the jets coming off toward the sun, and then there's a smaller one coming off at 7 o'clock.
But will we also be getting images from the high resolution, so we'll be getting a tighter close-up of this comet later?
Yeah, the high resolution images need to be deconvolved because they have to be processed a little more than the medium resolution images, so we'll get even sharper images of this comet, although it's already extraordinary. It does look rather like a peanut, though.
Well, there was some concern. Folks were worried that it would be really 2 comets and that would break apart, and there was some concern about that, but it looks like it's a solid structure there.
Yeah, it does. It is a solid structure, although comets do break apart from time to time. You can see that this one is so oddly shaped. Scientists often think of celestial bodies as roundish, and this obviously is not roundish. It's peanut-like. So Mother Nature has yet again pulled the rug out from scientific
Does it every time.
ideas.
All right, well, Don, thank you so much. I think all 5 are down, and very impressive. Everything we hoped for. We got a jet, and just the right shape. All right. All right, well, we'll be coming back live in just a moment. We'll go back to the room.